Okay, hey geometry students, welcome to our Unit 2 Triangles, week number 2. We're going to focus on two big ideas this week. So week 2's focus is on altitude and median. So if you want to make like a title of this page, this is week 2 notes, and we're going to be focusing on altitude and median. These are two vocab words that are related to triangles. And first I'm just going to start with a little warm-up just to get us acclimated. And we're just going to think about where have we heard these vocab words before in like our everyday lives, in the real world. So for number 1, what do we already know about altitude? Think about like if I ask you what's the altitude of a mountain, right? What does that mean in words? If we look at this visual, right? Notice this chart. We start at sea level, that's the very bottom, and as we go up, it labels them like this is a high altitude of 1,500 to 3,000 meters. And then a very high altitude gets to from 3 to 5,000 meters. Extreme altitude is over 5,000. And there's this zone called the death zone, and that kind of sounds intimidating, right? This is supposed to be Mount Everest. So when we think about like why is it extreme, what makes it like scary up there, if you've ever heard about like climbing mountains or what it takes to like climb Mount Everest, there's less oxygen as we go up. So as you go up in altitude, right, and altitude is kind of like a super fancy word. I'm just making my pen a little thinner to see it easier. So as we go up in altitude, which is a fancy word for height, right? The oxygen goes down, and that's why they say it's like a death zone, because there's very, very little oxygen at that point. So altitude is like a fancy term for height, right? If I ask, like, what is the altitude of me, right? Here's a little person, maybe this is Miss Goldenberg. My altitude is 5 feet 7 inches. That's how tall I am. And one thing I want you guys to think about when you get measured at the doctor's office, you know how you have to stand really, really straight and have your back against the measuring tool, right? The reason why is because when you measure your height, you have to stand straight up, right? You have to be like as straight as you can. You can't be tilting. So you and the ground, you want to be making a right angle with the ground, a 90-degree angle. 90-degree angle with the ground. And that's going to be an important idea as we continue, so keep that in the back of your mind, right? You're like feet. Maybe it's easier to picture this with like my feet, right? My feet and the ground are making a nice right angle. So if you kind of envision like my feet are like one next to the other, right? My feet and the ground are making a nice right angle. And then the other vocab word we're going to talk about is median. And median of numbers, right? Back in like middle school, you probably were told, find the median of this list. And if the list was in order of littlest to biggest, you were like, aha, and I just cross them out and I look for which one's in the middle. Ta-da! The median, the middle, is 89. So median is a super, super fancy word for middle, just like altitude is a fancy word for height. In the next one, how does the median change? It looks like I've taken away one of my numbers. So now, when I go through, if you remember back, this might be a little while back, the way you find it when there are two numbers is you find what's in the middle of both of them. And this kind of connects to our midpoint idea where you add them and divide by 2. So let's see, 80 and 80 is 160. So we have 169, 172. Divide that by 2. I'm just going to do it on the side because I don't have a calculator. I know 2 8s make 16. Carry the 2, and 2 6s will make 12. So it looks like it's equal to 86. That would be what's right in the middle of 83 to 89. You also probably could have counted that, right? Counted how far apart they are and found right in the middle. So all I wanted to do here is just kind of get us thinking about where we've seen these words and think about the fancy version altitude and median, and the normal word for it, height and middle. And now we're going to see what it looks like in math. So I'm going to pause the video and I'm going to write out a definition real quick for each of them and draw a picture, and then I'll unpause once I've finished my little drawings. Okay, so I've just unpaused the video, right? And maybe while the video is paused, that would have been a good time for you to also pause and draw out the table, right? If you haven't, maybe pause it now and draw out this table. And our two vocab words are altitude and median. So the altitude of a triangle is like the height of a triangle, right? And because we measure height with a nice 90 degrees to the bottom or the floor, right, it has to make a 90-degree angle with the base. So if you look at the picture to the side, my altitude is that green line that I've highlighted there, and the altitude goes from one of the vertexes, right? We call these points like, that's like a vertex, one of the points along the triangles, right? All of these are vertexes. So we go from the vertex straight down to the base, which is that side right across from it, and it hits that base at a nice 90-degree angle. Whereas the median kind of has a similar look, right? You start at a vertex and you go to the middle of the base or the side across from it. So notice that that yellow line is my median in picture number 2, right? And it cuts the base directly in half. So what's important about this is that the altitude always makes a right angle, and the median always cuts in half, right? Notice that they don't both do the same things, right? So kind of keep track of the difference between them, and we'll do some examples to kind of practice. The first example, number 1, says below are two triangles. One has an altitude drawn, and one has a median. Which is which, and how do you know? So I want you to pause the video, look back at your definitions, and try and do this one on your own. Unpause when you're ready to check your work or if you need a hint. Okay, so the first one's an altitude, right, makes 90 degrees with the base. The second one's a median because it cuts the base in half, right, or it bisects the base. If you like that way of saying it better, feel free to change the definition box. Like if you feel like connects the vertex with the midpoint of the side, if that's kind of like a little bit wordy, right? If you would like to, you could change it to, it's a line that bisects the base, right? And then it goes from vertex to a base. Like, feel free to change it if you feel like that makes more sense, that it's a segment that goes from the vertex to the base, and it happens to cut the base in half. Let's try a couple more. This practice problem says to draw the altitude from vertex A in each triangle. So starting from vertex A in the first one, remember altitude makes a right angle. I want to go straight down and make a right angle at the bottom. This next one is kind of weird because if you start here and you want to make an altitude, it goes down and it hits the base where it makes a 90-degree angle. Notice if you move it like to the right or to the left at all, it would not make a 90-degree angle, which is kind of interesting. And then this last one is like a weird special case. Starting here, right, if I'm going towards the base like this, that's not going to be a right angle. The only way to make a right angle is to just go straight down, right? Straight down is kind of the big idea for how you make them. So it's you go straight down and make a right angle. So for this one, you kind of have to envision if you were to extend the base, like kind of do a little dotted line, that is the same space as the base, right? If that line just kept going, that would be where it is as well. So this one's kind of a weird case. Generally, though, the altitudes are inside the triangles that we'll see. This one is another good practice problem. How many medians does this triangle have? Try to draw all of them in the triangle below. Remember, median connects to the midpoint, so this is like my midpoint, right? I would go from here across. But that's only one perspective. If you kind of turn your piece of paper, like I'm physically turning my tablet right now, what if I wanted to do like the middle of this one, right? I'll do one tick mark each. This one connects across to C. And what if I'm turning it one more time? What if AC was what I wanted to cut it in half? Let's pick a different color. I'm going to do 1, 2, 3, 1, 2, 3. That would connect across to point B. And I don't know how I did that so nicely, but if you look, there is one point where they do meet in a triangle, so that's kind of like a cool point there, where all your medians meet. And then let's look at a couple more. We've got a couple practice problems here. So practice problem C says, find the measures of all the angles you can with measure CAB. So following that with my highlighter, this angle, the whole thing is 84 degrees. And they also told us that AD is an altitude. That means I'm allowed to assume this is a 90-degree angle. So that means that this is 90 degrees. I've got 42. If I focus just on this green triangle here, using my sum of angles of a triangle is 180, right? I can do 180 minus 90 minus 42. Let's see, that's going to give us 48, it looks like. So it looks like that top angle is 48 degrees. And we are looking just for all the other angles. If I know that that top is 48, right? If I know the whole big yellow angle is 84, I could do 84 minus 48 to see what's left. Right? So 84 minus 48. It's going to be 36. I'm going to do that in a different color. 36. So that means this angle right there, let's make it just a teeny bit smaller. This angle here is going to be 36 degrees. And then to find the last one, right, we had the green triangle. I'm going to call it maybe the purple triangle. If I look at this purple triangle, the top angle is 36, the bottom angle is 90. To find the last one, we're going to do the sum is 180 again. So 180 minus 90 minus 36. That's going to come out to 54 degrees. So I've labeled that last angle as 54 degrees. So this problem really relied on knowing altitude meant a 90-degree angle, and knowing the sum of the angles of a triangle is 180. That's going to come up quite a bit this year. This next one says, we've got a little visual of a triangle. We're looking for FE. That's what we're trying to figure out how long that side is. We're told TE is 8, and we're told that G to T is a median. So thinking about what can I mark in my picture if I know that that's a median, that makes me think of middle, right? So that hits the side in the middle, right? It bisects the side or cuts the side in half. That means the other side should also be 8. And if we're looking for F to E, that's the whole base, that means FE is going to be 16 units long. Okay? So you'll see that there's a lot of different things we can do with these two new vocab words. This next one is going to be similar, right? We're still dealing with a median, but in this case, given FI is a median, so these sides are equal, we're going to do a little bit of algebra. So I'm told that G to E is 3x minus 5, or 3x plus 5, excuse me. And I'm told that I to E, so just this part here is going to be x plus 6. So we need to figure out how to write an equation that's true. Let's see. That means if IE is equal to IG, this one would also be x plus 6 big. So couldn't we say that x plus 6 plus another x plus 6 equals the total of 3x plus 5? Let's try and solve this equation. 2 x's, 12. Right, I'm going to subtract 2x on both sides. I want to get them all on that side because there's more x's. So it's going to give me 12 is equal to 1x plus 5. And then I'm just going to subtract 5 on both sides. So it looks like 7 is equal to x. And that's all they asked us to find. Nice. And then there's a couple of algebra problems for practice. Why don't you pause the video and try these out on your own and see how you're doing with your algebra setup. Unpause when you're ready to check. Okay guys, here are your answers. Notice the first one had us start assuming that we had a median, so you could set the sides equal, find what x was, and then plug it into the angle to see if it was or was not 90. Whereas the other one was kind of backwards. You started assuming an angle was 90, found x, and then plugged it into the sides to see if they were cut in half. Feel free to pause the video to verify any of the steps, and I'll see you guys on Wednesday.